Yesterday we had just talked about some gradient descent formula and their types of the gradient descent, some terminology of gradient descent, and we also talk about, okay, we didn't talk about the DSA part, resume part, and visualization part. Okay, should have just introduced with some introduction of it. And today we are going to do the same. Today what I have done is that analytical download and the validation thing. What especially I have done in that thing is I've just in the morning, in the early morning, I worked around some NTLK for just data cleansing. I collected some Twitter data in order to just justify that and make it useful to the others for the paper and the research thing. That's what, and with Analytica, I'm just trying to have some keywords out of it, some important words. Overall, I just try to analyze it with the help of Analytica, words, emoji, and also use the Python library emoji to just replace the emoji because most of the tweets are having emojis in it. And then next, what I have done, okay, I have also performed some DSA programs. Okay, I'm going to show you the DSA program for the next time. In the DSA program, what I have done, I have just implemented Fibonacci 1 star format, 1 billion term format. Okay, I'd like to discuss some advanced patterns in the followed by the formation the different kind of patterns with the help of in the programming. Okay, I'm going to rephrase it. There is main trick which you can follow to just form any kind of pattern. You just have to analyze. If it's just a star pattern, then analyze the first row, second row, third row accordingly. There is major mainly three key points which you have to draw: columns and elements. Columns and element can both be done in a similar step, or both can be done together only, but rows will be most of the time rows will be given by the user. Columns we have to just see the if the pattern given like this, just a star, there is some distance space between the start line and the star is forming in the middle of that number. Then you have to just put some space over there. You just count the space. Most of the time the space will be uh, row number minus 1. That what is the okay, that's right. The space would be the total number given by the user minus row number. That should be the space over there in the starting, and the pattern you can just print in the second loop. Okay, how you are going to do that? That's the three major key points you have to follow. How you are going to do that? You have to just creating a for loop which is 1 to n. Remember, 1 is equals to less than equals to n, and another for the rows, for just traversing over the rows, and next loop under that in this only for traversing to the columns. In the next we just perform, we can just create another variable, or we can just run our loop of our column loop only to the n minus I, that is I is their own number, n is the input given by the user. That's much we are going to print the space, and after that we can add another print statement, see out. Most of the computer programming programs I've done in the C++. So you have to just see out the pattern you want to print out, then just semicolon, and then next again you are going to do it. And after the column you have ended, just print out the end L, see out end line, semicolon. That will just going to the next line. Okay, yesterday I have done two majorly point like the star formation. First we are having first star in the center, then we are having 3, then we are having 5, then we are having 7. There is a main key point in like how you have to draw that elements. You have to just multiply it to multiply by n is the total number given by the user minus I. So suppose user given 10, 2 multiplied by I minus 1, if I guess right. Yes, 2 multiplied by I minus. Okay, if you are in the first row, that is I is to 1, 2 multiplied by 2, 2 minus 1, 1, 1 star will be planted in the center. Before this, you are going to print some space. In the second line, You are having I is equals to 2, 2 multiplied by I minus 1, 2 multiplied by I, that is equals to I is equals to 2, 2, 2 to 4, 4 minus 1, that is 3. That's how you are going to form 3 star, next by followed by 5, next by followed by 7, then again 7, then again 5, then again 3, then again 1. That's a common. You are just drawing the upper half of the with the two loops, then you are just performing it once again by just reversing the initial and the condition of its final condition of the second loop, second whole loop, that is starting with the n and it is equals to 0. Okay, that's the two. Another one is I've just drawn a palindrome of number, which is just a trick. I'm going to discuss it all later on. And today I also discussed about gradient descent, which we have done. Okay, now we are going to talk about image processing. In my today's class, image processing class, what we have done, we have just understood like how image is formatted in the digital way. You are just clicking a picture from your phone or any other camera. The mechanism behind the capturing a picture is just exposure captured by your camera. Exposure, there is various frequency or wavelength captured by your camera and just printed to another screen. We can say it's just capturing it and just forming that on the another screen. That's how ancient the diagrams and the sculptures working in the ancient time. They are just keeping it like you have seen the carbon copying thing. Na? If you are just want to draw this structure, you have to just ink it and then just paste it over here. You are going to have it. That's how the camera thing is working. Just going to exposure by just placing some light or whatever the light it is having, that normalize, just capturing those light and just having over here. That's how the image processing working. Camera is taking the pictures and then the oh okay, in the transformation in the normal image we are just converting into having it into digitalized form. We are including around three process. The first one is the sampling, another one is quantization. Okay, there are only two. Only sampling, we are just dividing the whole image into grades. In the quantization, we are just assigning some numbers to it according to their layer and according to their depth of their level. Or in the another way, we can say that's the spit level of their okay, the gray level. Another word is gray level and the level of the image. In the grid, okay, there is three things you can do majorly in the image processing. First is the doing on the minimum level. On the low level you are just capturing an image into a digital form, and then we are just transforming it and recognizing the image and data of the image. In the third, we are having higher level. In this, we are recognizing any kind of object in our image, like we are having an image, transferring that to the digital image, that is on low level. In the middle level, what we are doing, we are just analyzing the data of it, how many grids we are having, how many data, how many values in that gray values we are having that. On the higher level, we are just recognizing like the image is often road and the vehicle in it. Now we are going to recognize on the higher level, we are going to recognize the model of the vehicle, the registration number of the vehicle. That's what done on the higher level. Okay, this all the some little explanation of the image processing and what you can do in that. Now we are talking about the image handling. Okay, so today the assignment was given, which is pretty interesting in the terms of programming. I am going to share it whenever it will complete, or probably it will going to be complete tomorrow only. Okay, the one thing which I want to mention over here, there is some we can after handling, after observing the image, you can just convert it into, you can just play with it, you can just alter the data of it. There is two types we can have it. That's it. Majorly we can do the okay. I was talking about the okay. I was talking about I just forgot. No, I was talking about the image handling or image alteration we can do with the image after editing the image. What we can do, we can just add some. Okay, there is a four ways we can just alter our image. The four ways are just point to point, the masking, and another is linear and non-linear. Linear and the non-linear both can be compatible with they both are not all of them are not exclusive. They all are inclusive. In the point thing, what we are doing here, we are just changing each and every pixel one by one. In the masking, we are just taking a single pixel from a grid and just taking some nearby or some surrounded pixels, and we are performing some alteration on them. It will be done simultaneously for the in order to complete it. Okay, there's the four things what I was talking about. The brightness and the contrast, which we can do it in the brightness. In order to increase brightness, you have to add a common number to all of the pixels. But just remember, if your image is just of 4 cross 4, 4 cross 4, then your the value of the gray level it should not go beyond the 32. If you are just adding some value in it, let's say some of the pixels are having 30, 25, and you are adding around 7 pixel in it, then it should not go beyond the 32. If it goes in, it is just going to start again from okay, it's just going to create error. If you are just handling the error, it will again going to start it from 1 2, which is just an inverse of it. It doesn't want that. Okay, so what we can do in that case, there is an issue which I am talking about. So what we can do over here, we can just transform, we can just put the maximum value to the okay, we can put maximum value to the highest level of contrast we can have. Like in the 4.4, we are going to have 32 level of it. In just increasing the brightness, decreasing the brightness, you can just subtract some values. Okay, the contrast we have to do. Okay, just wait. Okay, it's 13. I'm going to finish it before 20. Just talking about contrasting. In the contrasting, what we are doing, we are just multiplying the each pixel with a single number. In this, again, we have to going to say we will face same issue. We will face same issue like if you are just multiplying some number, it is just increasing it is just going beyond the limit. You have to just keep it on a limit. If it goes, then just put it on its highest limit of it. But that's about image processing. And now we are going to talk about our explanation in the recommendation. This is very good and very interesting topic. Many of us, if you are living in the India, I'm not sure about the outside countries. Many of us can relate to it. It's something, in other words, we can say गंजे को तेल बेचना, गंजे को गंगा बेचना. A salesman can sell his comb to a blind man. The man is not having good hair, growth hair, good hair. Well, that's the thing. Giving a proper explanation behind why you are recommending that. Okay, there is a famous quote, "Sell me this pen." And if you are having good explanation, good kind of constraint solution problem, you can absolutely sell that pen. That goes very off topic. In the contrast, in the con, in the explanation of the recommendation, what we can do, we can have the I am not remember this topic. That's all. I am not remembering that topic. Thank you for listening me. Okay, you guys are not listening. Okay, I'm going to perform this daily vlog, video log on my regular basis for just my improvement. I don't want, there is nothing my personal intention to anyone, if just anyone